Hey guys, let's take a look at factors that are sums first. And in this one, let's go back. Remember how to do the ones on the left, right? We just simply take out, we turn them into binomials. And we figure out what two numbers multiply to give us negative 28 and also add to give us negative 3. And the answer to that is positive 4 and negative 7. Okay, and remember these over here, right? We just look at this and we say, okay, what is the biggest thing that goes into all three of these? Okay, that's a 2. All right, x to the 4th, x to the 3rd, x to the 5th. You know, okay, oops, maybe x to the 3rd goes into all of those, and then there's a y, a y, a y. You pull that out, and then you see what's left. If you can factor the trinomial and the two binomials like that, you do the same thing, okay? Today we're going to look at a slight different twist on that, but let's look at this one first. And a lot of algebra is, does it work with actual numbers? If it does, we can just make it an algebraic, law or whatever. And if you look at this, you could go, okay, what is 5 times 4 plus 7 times 4 minus 8 times 4? And if you did the math, you could go, well, that's 20 plus 28, 48 minus 32, well, that's 16, okay? We know the answer is 16. What you could also do is, since all three of these terms are multiplied by 4, you could just take this part here, the 5, the positive 7, the negative 8. In other words, you could stick them in a row. 5 plus 7 minus 8. And then go, okay, I'm just going to do that as a hunk and multiply. Instead of having to do it, say it 3 times, I'm just going to go, all this is at once, and that's going to be multiplied by 4. Well, what is 5 plus 7? 12. 12 minus 8 is 4. 4 times 4 is 16. At some point, somebody in the past kept doing this and it worked every time and went, I can do this with it, okay? And of course, we're not going to just stick with numbers here. We're doing A's and B's and X's and all that jazz. So let's look at one. This is what it looks like. All right, if this works, and you can just go ahead and lump all those numbers on the outside that are being multiplied by the same number in one hunk and then just multiply by that number once, then let's do it with algebraic stuff, okay? Now, go ahead and copy. Just give yourself a second to copy this, or pause it or whatever. Okay, now if you notice this time, the a plus b is a part of all three of these. So what we can do is we can just lump this other stuff, this and the minus x and the minus 6, we can just put those together as one hunk. Then we can go, okay, I'm just going to multiply the entire thing by a plus b one time. So in other words, this is the a plus b that we're going to multiply by the entire thing. And the entire thing that's left is the x squared, is the minus x, and then the minus 6. And that's a little bit simplified, okay? Now if you look at this, you go, wait a minute, that's a trinomial. Okay, let me see if I can, bust this into 2 pieces. Well, let's see here, 2 binomials. Now it's going to be x and an x. It multiplies to give you a negative, so it's a plus and a minus. Are there 2 numbers that multiply to give you negative 6 and add to give you negative 1? And of course, the answer is positive 2 and negative 3. And so there we go. That's it. All right. We just take this, since it's there to every single term that's attached, we'll just do it once. And then we'll just put the rest of the terms and then do them in one hunk and then, factor that out if you can. All right. Here's another one. Go ahead and pause. All right, well, this is the term that's part of all 3. So we can just pull that out and just do it once. And what's left? I have an x squared plus a 9x plus a 20. And I'm sure you notice that's a trinomial. And very likely you'll be able to factor that. And this time, of course, we will be able to. You tell me. Give me 2 numbers that add up to 9 and multiply to give you 20. Yes, that is correct, assuming you said 4 and 5, or 5 and 4, and that is your answer. There we go. Okay, all right. Let's take a look at this one. Go ahead and pause that if you'd like. All right, this is slightly funkified because we got one extra thing here, if you notice. Okay, but we do know that this x minus 1 is common among all 3 terms. So let's just pull it out. I got an x minus 1, I'll just stick it out here. All right, this time, even though there's something up in the front and the back, it's still getting multiplied all together, right? So we'll just stick this all together. Mx squared plus 7mx and then plus 10m. Now if you look at this as one chunk now, you look at that and go, wait a minute, there's an m in all three of these. So x minus 1, and I got my m, I'm pulling that out. Okay, if you want to put it in parentheses, go ahead, doesn't matter. All right, I got an x squared, I got a 7x, and I got a 10 left. And I'm sure you probably noticed that, aha, another trinomial, we can knock that out and go, that's going to be x there, and x, and then a 10, excuse me, a plus and a plus. What two numbers multiply give you 10 and add to give you 7? That's a 2 and a 5. And so if you want to, you can just put, I don't know, you could even put this if you want, m on the front end and then, you know, x minus 1 on the back end. That's fine, doesn't matter what order you put things in if you're multiplying. Just know that your answer in the back of your book, if you're checking these, might be slightly different order. As long as you have all those elements in there, you're fine. Okay, all right, let's look at the second half is, we're going to do some things with pyramids and some formulas. So just a quick basic look out of this. A vertex of a pyramid is like the point. Lateral means side, so there's an edge. The axis of the pyramid goes from the center of the base of the pyramid all the way to the vertex. Pyramids can lean or they can be right pyramids, which means they're at a 90-degree angle. The altitude is the distance between the base and the top, which is the vertex. Okay, doesn't matter whether it's leaning or if it's straight up, it's still the altitude. All right, a lateral face just means, you know, that's just the side, the face of the side. We'll find a surface area of those pretty soon here. So this is again a right pyramid, which means this is a pyramid whose, you know, it's at a right angle. Its base is, so it goes right up. It doesn't matter. The nice thing about these, doesn't matter if it's a leaning one way or the other way. The formulas are all the same. You don't have to worry about that at all. So these are called regular pyramids. The reason they are called regular pyramids is because all of the lateral sides and the angles are exactly the same. And this is there's a pyramid that has a base and three, I guess you could call them lateral faces. There is one with 4 and so on, and there is one with 5. And it doesn't matter. We'll see some neat things that happen with this. A cone, look at the drawing of this cone here, is slightly different. You can tell what's the deal with a cone. A cone has a base that is a circle, sometimes an oval, but we're just going to deal with circles. So everything's exactly the same. With a cone, very similar, except for the base is a circle. Now there are some different ones, like this right cone. Of course, the base is at a right angle to the to the axis and the vertex and so on. So, all right, there is something you need to know. Make sure you know what this is. When somebody says the word or the term slant height, that is, they often use the letter L, and that is from the base on a cone all the way up to the vertex. That's how tall it is, and we're gonna use that in a second to figure out some things about cones. Okay, let's go back first and go the formula for the volume of a circular cylinder. In other words, here is a circular cylinder, right? Looks like that. It's a giant can. I don't know, let's say it's a really big can. There you are, assuming you're very skinny and have no eyes and no hands. Okay, we could call this, I don't know, we'll call it bit o dolphin tuna. Okay, nice little dolphin bits in there, kind of, let's see here, kind of hanging out at the edge there. It's kind of coming out there. They got caught in the net or whatever. That's terrible. Okay, so the formula for this, let's say it's 10 feet tall. And let's say the radius is, I don't know, 3. All right, what is the volume? In other words, how many cubic squares will go into this entire thing? Well, the volume, the formula is the area of the base times the height. All right, the area of the base times the height. So the area of the base, we know how to find the area of a circle, which is pi r squared, right? So if you go pi r squared is the area of the base, r squared, the radius squared would be 9, and that'd be times pi. times the height, which will be 10, and the volume will be 90 pi. In other words, 90 times 3 is like 270, so it'll be about 280-ish. 280 cubes of delicious bit-o'-dolphin tuna will fit into that giant cylinder. So, it's pretty good. Looks pretty good. Okay, yeah, good enough. Okay, well, this is nifty, or groovy, as you teenagers say these days. Easy formula for the volume of pyramids and cones. Not just pyramids, not just cones, both of them. No complicated fractions or decimals or anything crazy. You just go the same thing as that, except you divide it by 3, and that's it. That's all there is to it. Very easy, very simple, almost magic. I mean, that's kind of strange that would happen. But anyway, to me, it shows God's universe, orderly, mathematical, incredible. So we're going to use this finding volume of cones. In other words, let me just make an example. If there were a giant, let's say, cone, and it fit exactly in this giant, if somebody scraped and licked every corner of that bit-o' tuna, and you put a giant cone hat, and it fit exactly in here like this, and it'll all touch the sides perfectly and drop right in there, and the vertex, the point of that hat, exactly scraped exactly the top of that cylinder, then all you would need to do is figure out, forget the cone, figure out what the volume of the whole thing is, which we did, then just divide by 3. 90 divided by 3, I got ahead of myself, is 30, so you just put 30 pi. There you go. Neat. Okay, let's do one. Find the volume of the right rectangular pyramid. Okay, now again, we're going to find the area of the base times the height, and define, let's do it this way. Pretend that this is just a cube, or let's say some kind of a rectangle, like a giant box, right? Okay, if this were a box, we would go, oh, the box is going to be, we'll say, oh, this is 9 times 7, and then we go, oh, it's 8 high, so 9 times 7 times 8, well, 9 times 7 is 63. 63 times 8 is 504. All right? But that's not what we're figuring out. We're just figuring out what the pyramid is inside that thing. So we're going to we're going to divide this entire total by 3. All right? So if you did the long division, you would say the volume is 168. We'll say cubic inches, because that's what it is. All right? And that's all. Just divide by 3. All right? Here's another one. A right circular cone has a base of radius 6 feet and a height of 8 feet. Find the volume of the right circular cone. Well, all we need to do is imagine that this is a big circular cylinder with juicy dolphin bit filled tuna. We figure out what that is, and we just divide by 3, and we're done. Here's a right circular cone. Boom, there it is. That's 6 feet here. We find that, we multiply by the 8, we just divide by 3, right? Okay. Well, let's figure out what it is. Pretending, if you want to visualize it like this, feel free to draw it if you want to. In other words, pretend it's like this, and then the radius is 6 feet, okay? Well, what's the area of the base then? If the radius is 6, you'd go 6 squared is 36, then times pi, right? Okay. Then we go 36 pi, then we multiply by 8, and that would give us 288 pi. That's if it were a cylinder. That's the entire volume of that entire thing. It isn't. It's a cone. So all we need to do now is divide by 3. And we get 96 pi. Now this is good. In the back of your book, it has the actual answer. Fine, just make sure, 96 pi, it's about 100 times about 3, right about 300. So your answer should be right about 300. All right? Okay. Let's look at this. Surface area of this regular square pyramid. And this is not the volume. This time we're finding surface area. So make sure you pay attention to that. All right? So the surface area, we are going to find the area of 1, 2, 3, 4 sides and the bottom. Okay? It says it's a square pyramid. So we know that each one of these sides is 6, 6, 6, 6, and 6 over here. So we know we've got part of it. We got 6 times 6. That's the surface area of the bottom. All right. All we need to do now is figure out, okay, well, what's the surface area of each triangle? Well, you know how to find the area of a triangle, right? You take the base, you multiply it by the height, and you cut it in half. So we're not doing 5 times 6 for one of these. We're doing 5 times 3. So each one is 15. So we have 15 here, 15 in the back, 15 here, and then 15 here. So 15 times 4 is 60. And that'll be 96. And then, of course, if you want to put the unit, that'll be square centimeters. And there you go. All right. Second thing you want to write, I would write this down on a card if I were you. And we're going to find the surface area of a cone. The surface area of a cone, not the surface area of a pyramid. The surface area of a cone. If you think about it, the surface area of a cone, it's kind of weird. I mean, like, it wouldn't be that hard to figure out the surface area of the circular base. You just use pi r squared, right? But the surface area of a cone, like, how do you find that? You know, if you unfold that, how do you, what's the, huh? You know, how do you do that? Okay. But all we need to do is you can just go the base surface area, which we know how to do. That's pi r squared, right? The lateral surface area, we don't know how to do that yet. All right, we'll find that out in a second, okay? This, remember that term slant height here? That's the distance between the base of the triangle and the vertex, okay? For a right circular cone, that's what that looks like, okay? The lateral surface area, this is what you want to write down. Write this down. To find lateral surface area of a cone, you're going to multiply pi times the radius times L, which is the slant height. And of course, they're going to give you the slant height in these problems, so you can actually do the problem. All right? So let's take a look at one. A right circular cone has a radius 8 and a slant height of 10. Find the surface area. Okay? Well, again, the surface area of a cone, we can go back, is pi times the radius times the slant height. Okay? We'll call it pi times the radius times the slant height. All right? Well, piece of cake, right? That'll be pi times the radius, which is 8, times the slant height, which is that. So it'll just be 80 pi. And again, if you want, that's 0. If you want to do the arithmetic in the back, go ahead and do it. All right? Okay. Let's take a look at some of these practice problems and try A first and see what you get. Okay, if you factor out A, you would get A plus B times x plus 3 times x plus 5. You factor out the x squared plus 8 plus 15 into those two things. All right, pause it and try B. All right, B, C gets factored out of that entire thing. But don't forget the C at the very end of your answer. So what's going to happen is you're going to get M minus B. You know, the x minus 6 times x plus 4, you will have had x squared minus 2x minus 24. Okay, pause it and try C. All right, C will be 320 cubic centimeters. That is your volume. All right, let's go with D. Oops, should have told you to pause it. Okay, D is 216 pi square meters. All right. And that's it for today. You guys have a good day. We'll see you next time.